Okay, so we will go ahead and start with the review here. It's very important that it's very important to write down these three forms because we are going to need them later on today. So and yeah, for both questions, we are going to need them today. So first, take a moment to see if you can still write down the root form and then the standard form, and then the vertex form. Okay, so we can go ahead and do that first. All right, and if not, it's really a good time to catch up with these forms. Okay, all right, and then the vertex form would be now. One thing about the vertex form here is that we are not going to have the b value here because if you think about the b value, you can actually combine the a and b together. So we have one less uh, item to worry about. So that's why for this particular topic, okay, we will go ahead just treat a and b together as a single a. Okay, so we don't have to worry about the b value. All right, now, and just in case if you wonder, these a values are all the same, okay? If you have an a value from the root form, it would be the same a value from the standard form and the vertex form. Okay? So these are the three forms, and we will use them. And it is very crucial that you know and you could write down these three forms at any moment. Okay. It's also very important that you can make sense with these forms, uh, whether it's for the course or for the SAT or for any kind of information purpose. Okay. And the next one, it's that you are given a system of two equations. Okay, you have these two equations and you are asked to find out x and y. Now, the reason why I want to go over this easy question, systems of equation, is because we are going to need to consider solving systems of equation for some questions today. So it could be a good time to take a look at it. Now, as you can see here, there are a couple of ways you can do it. You can do it by elimination. And if I choose to do elimination, I probably would choose to change the second equation with by multiplying a -1. Okay, so that would be pretty nice. And that would make my life also very easy. We add these two equations together. So we got x equals to 3. See, very fast. And then if x is equal to 3, that means 9x plus y is equal to 0. 9 times 3 plus y is equal to 0. So 27 plus y equal to 0. Y it's equal to -27. Okay, so these are the x, y values. Okay, alternatively, of course, do this by you can do this by substitution because you can get y by itself like this, and then you can just go ahead and substitute. All right, and then you can still get the same answer. So x is still equal to 3, and then you substitute and you can get the y equals to -27 the same way. Okay, so we might encounter situations like this. It's always a good thing that you know how to do systems of equation. Okay, here's something I also want to tell my students that I mean, I nobody can tell you what to do like every single time. It's you that need to tell yourself that, oh, I need to go ahead and do this. I'm capable of doing something. Okay, I'm capable of finding two unknowns if we're given two equations. So the trigger, okay, the trigger that you have to build is that um do you see two unknowns? Okay, if you see two unknowns, you would check the box. And the next thing that you need to also observe is that do you also have two equations? Okay, two separate equations. And if you say, yes, I do have two separate equations and I have two unknowns, then you can give yourself a smiley face because that means you could find out the two unknowns values. You could. What are they? I don't know, but you could at least try to find out those two values. Okay, this will be very useful in math, and if you take physics now or later, that will be very useful. Okay, so our topic today is this. Okay, our topic today is to kind of do the reverse thing. Okay, so in the past we have the equation, we write the we have the equations, and we extract the information from there. We had the equations in maybe vertex form, root form, and standard form, and we say, oh, can you tell the y-intercept? Can you tell the vertex? Can you tell the roots? Okay, we did that. And now it's like going backward, and we're like, oh yeah, so now we're giving you the points. Can you go ahead, give us the equation? Now, for the videos today, I will only go over the example part, which is the left-hand side of the handout. You will finish the practice part, and you can always check the answer key for your to check your answer. Okay, but for today, we will only go over the examples part. All right. So now, so for the first example, take a look first. Okay. Now, you have an axis of symmetry. That's x equals to -2. And then you have the graph passing through 2 points, right? Now, if you take a quick glance, you might not realize anything special, but I'm going to ask you to observe the given information one more time. And I would say, can you see anything special? Okay, can you see anything special? Now, if you say you can't find anything special, then I would say, no problem. Now, sometimes a good idea to draw out some sketches, okay? So, you can see the information better visually. So axis of symmetry, it's -2 comma, -2, okay? So you have -2 right here, okay? So that is your axis of symmetry. And then the graph passes through, -2 comma -3. So we can plot a point, and that point, it's going to be, let me go ahead and have a little visual effect. Let me do the axis of symmetry with a gray line so that you can see better. And then I'm going to plot the -2 comma -3. Wait a second. Now, if you did not see anything special, and now you look at this picture, can you see anything special? We have a point that's on the axis of symmetry. What could that be? Okay, what could that be? Okay, so you can say, wait a moment, wait a moment. That is the vertex. This is the vertex, right? So now if you're given the vertex, I mean, if you are going to write an equation, what form would fit better than the vertex form, right? So you can have a times x minus h squared plus k, which is the vertex form. And now we know, sorry, my bad. I should say this only. We know the h and k. So at this very moment, let's go ahead and substitute our h and substitute our k, so that we have x plus 2 squared minus 3. How wonderful. Well, but we are missing one key information, and that is this. Okay, what is this? Okay, now I'm going to go through a formal way of finding out the a value. Okay, and then at the end of the video here, I will also go through a little bit faster way if you are sensitive to information. Okay, now The key thing I want to go over here is that if you want to find A, you would have to know X and Y. Okay, you would have to. If not, how would you find A? And understand that this equation is a representation of all the points on the graph. Okay, so if you have a point on the graph, then you can plug it in. And do we have a point on the graph? Well, we can rest assured that we do have a point on the graph. So therefore, we can now set up our substitution. Okay, I'm going to say, well, both x and y are -1, -1. So let's go ahead and substitute and see what we get here. Okay, so we've got 1 squared minus 3. I'm going to add the 3 over. So you have 2 and a times 1 squared, which is 1. So a is equal to 2. So you have our equation, which is y is equal to 2 times x plus 2 squared minus 3. Okay? So it's very easy. Okay, it's very easy. So you are given the vertex, okay? And we plan to give you this vertex thing so that you can have an easy life to write down this equation, right? So you have an easy moment to create this equation. And also, all you need to do is to substitute a point so that you can find out what the A value is. Okay, so that's how you do it. Okay, anytime that you have a point, you are more than welcome to substitute, and we will practice this kind of substitution in almost every single question. Okay, so well, almost. Now, so as I said earlier, so that's a way to find out the A value. That is also an easier way to do your A value if you are sensitive to information. Now, what you can see here is this. You can see that from the vertex to the next point, it goes to the right 1 unit. And based on our knowledge of graphing, we should go to the right 1 unit and up 1 unit if the A value is 1. But the fact that it's going up by 2 units, what does that mean if you are only looking at the perspective of vertical stretch? It is stretched by a factor of 2. That means the A value must be 2, right? So we can use what we learned before to practice right here. So again, if you're sensitive to information, if you can actually see the graph or you create the sketch of the graph, that will be really, really useful. Okay. All right. So that's the first problem. Okay. I hope you like this first problem. It's not that hard. I think the key technique right here is the fact that you have a missing A value, and you could find out the A value by using the XY values, the coordinates from the given point. Okay, so we will always give you enough information to find out the equation. So the key for you is that you have enough information to create that equation. Okay, so go ahead, do the practice, and then check your answer. And in the next video, we'll go over the next question. Okay.